Good morning and welcome to this course titled Power Plant Engineering. So, course code ME350. So, this course is meant for undergraduate BTech students in mechanical engineering. So, here in this course we will study in detail about how a thermal power plant engineering works. So, the basic theoretical operation and details about each and every components that is involved in a thermal power plant. So, myself Dr. Manoj Kumar Moharana, the course teacher for this subject. So, here you will find the details of my contact information. So, whenever you find any difficulty regarding the subject, you are encouraged to meet me personally, or either you can write to me over this contact mail IDs. And regarding this course subject, I have developed 2 pages. One is on the Moodle platform, another page on this Facebook. So, where regular updates regarding this course are available from time to time. So, students are encouraged to visit this web page links for regular updates related to this subject. And the syllabus and the lesson plan in detail for this course is available on this Moodle platform for this particular subject. The title of this course is Power Plant Engineering. The subject code is ME350. So, it is a 3 credit course. So, we will have 3 lectures every week. So, here the class timings for this semester for this subject is Tuesday 3:15 to 4:15 p.m., Thursday 2:15 to 3:15 p.m. and Friday we will have another class, that is at 1:15 to 2:15 p.m. This is a level 2 course. So, that means some foundation knowledge is required. So, that is the fundamentals of engineering thermodynamics is very much required to understand the details of this subject titled Power Plant Engineering. So, normally undergraduate students read this subject during 2nd or 3rd semester of their undergraduate program. So, it is assumed that students already completed this course on engineering thermodynamics. During this subject, students have already used the stream table. So, here also throughout this subject, the use of stream table will be very much required. So, that is why it is expected that students going through this subject know how to use a stream table and the corresponding molar chart diagram. The objective of this course is to acquaint the students about the generation of steam and the production of electricity, and to present some engineering calculations that is encountered in practice in running a thermal power plant. At the completion of this course, it is expected that a student will become familiar with the power plant systems, terms and definitions, and basic power plant engineering design calculations, and the students will be able to understand the basic components required for operation of a power plant and its related equipments. There are different sources of energy that are available for the humankind. So, one is your coal is the primary source of energy, then oil is another source of energy, and then some other sources of energy like your Hydel energy is available, then wind energy is also available, then the solar energy. So, these are the primary sources of energy that are being used by human being continuously. So, in addition to this, with respect to time, different other sources of energy are being developed like your tidal wave energy, geothermal energy, etc. So, here out of this list of energy sources, this coal and the oil, this comes under one category, that is called your conventional source of energy, where we also call it the thermal source of energy. Then the other remaining sources of energy, that we can group into another source of energy, that we call as a renewable source of energy. That means the storage of this energy is unlimited. So, it is not going to end, whereas these conventional sources of energy are limited in resources. So, it is expected that in near future it is going to complete its total reserve on this earth. So, that is why we needed to shift from this conventional source of energy to this renewable sources of energy in future. but the need of this hour is to have continuous generation of energy, having efficient engineering systems to harness the energy from different sources. So, in later slides we will see what is the importance of this thermal energy, basically considering coal as the primary source for obtaining the energy. So, that is why here during this subject we will study in detail about the basic operation of a thermal power plant, considering its very much necessity for the human being at present. So, we will start this course with one small line taken from by Thomas Alva Edison. I shall make electricity so cheap that only the rich can afford to burn candles. So, if you go to very olden days before the invention of electricity, we were dependent on candles for getting light during the night time, and the invention of electricity changed the everything in this world. So, now almost we are dependent on electricity for each and every aspect of our day to day life. So, electricity is considered as the most convenient form of energy, because here if you have electrical energy, we can convert into any other form of energy as per need at any point, at any time, at any place. So, that is why our objective will be to get electrical energy, so that we can convert this electrical energy very conveniently to any other form that we require at any time. So, if you go for the production of electricity, so here it explains through an animated diagram. You consider a coil placed between two magnets, and if you rotate this magnet, then electrical current flows through this coil. So, from this concept we started the use of the electricity, and when this electricity passes through an electric bulb, here we get light. That means, here this electrical energy generated gets converted into light energy. So, here in addition to this one, we also get some amount of heat here. So, the same concept can also be used for generating heat by having a simple resistance coil. If you allow the current to flow through this resistance coil, this electrical energy will get converted into heat energy. So, here we should first understand how we can obtain this electrical energy. So, here you see this animation tells you that if you can rotate a coil between a magnet, then we can obtain this electrical energy. That means, here we need to do something to rotate this coil. That means, we need rotational form of the energy, so that it can be used to rotate this coil. And there is a device called a generator, where if you rotate the shaft of this generator, we get electrical energy as the output, and this electrical energy can be used as per convenience for the need of the human being. So, we have to now think of how we can obtain a rotational form of energy, so that it can be connected to any generator, and from where we can obtain this electrical energy. This shows the actual photograph of a thermal power plant, which can be identified by very tall structure chimneys, and this plume of flue gases coming out of these chimneys. So, this shows the schematic representation of the working of a thermal power plant, where we are having a electrical generator connected to a turbine through a shaft. When this turbine rotates, the shaft of this electrical generator also rotates. As a result, we obtain this current out of this electrical generator. So, here our motive will be to rotate this turbine. For this purpose, we require steam at a high pressure. So, what we do is, we consider a boiler, we feed water into the boiler, then in the boiler we heat the water and convert the water into high pressure steam. And this high pressure steam, once it leaves the turbine, it becomes a low pressure with low temperature steam. Then this, if you want to reuse it in a boiler again, then we need to first convert this low pressure steam into liquid water, so that it can be pumped easily again into the boiler. So, therefore, we take the help of another device called a condenser, where with the help of cold water or coolant, we extract the heat out of this low pressure steam. So that this low pressure steam can be converted into liquid, and this liquid can be fed into the boiler again using a pump. So, this completes one cycle here, where water is used as the working fluid. Here, for the purpose of heating, we require this combustion of the fuel with the help of the air. So, this as a result of the combustion, heat will be generated, and this heat gets transferred to the water, where it is converted from liquid state into the vapor state. Then this products of combustion, that is known as your flue gases, which remains normally at higher temperature. So, we need to extract more amount of heat out of this one, and later on we need to throw it to the atmosphere, and it goes through a tall structure called the chimney, through which the flue gases go into the ambient atmosphere. Then here this coolant we are using here to extract the heat in the condenser can be reused by throwing this heat to the again to the ambient with the help of a cooling tower, where again we cool this coolant, so that this heat can be rejected to the ambient. So, here through this basic process we are able to generate current with the help of a turbine. So, here turbine is your the heart of this thermal power plant, where it gives the rotation to the shaft of a electrical generator. So, then we will go for this hydroelectric energy. So, this shows the actual photograph of a Hydel dam, where we obtained this hydroelectric energy. So, here also the same concept used. Here also we try to create a rotational effect by using the potential energy stored at a dam. So, here in this case we allow the water to flow through one small passage, and it strikes to a turbine, and here when strikes to the bucket of a turbine, the turbine rotates, and the shaft of this turbine will be connected to the shaft of a generator, and as a result the shaft of the generator will rotate, and finally we obtained electrical energy, and this can be used as per our convenience. So, here also the basic concept of generating electricity remains the same, use of a electrical generator. Then we will go for this wind energy. So, it has been exploited for thousands of years since the development of the human being on this planet Earth. The oldest application of this wind energy include list like extracting water from these wells, making flour out of these grains, and for different other agricultural application. And in recent times, with the development of science and technology, wind energy have also been used for generation of electricity. So, this shows the actual photograph of this wind turbine, where you can see there will be there is a tall structure above which this turbine is mounted, and it is having 3 number of blades here. So, here you see how this wind turbine is rotating in this case. So, the basic if you closely observe the wind turbine, you will see there will be blades which will rotate because of flow of the air over these blades, and these blades are mounted on a shaft. So, it will be the shaft will rotate as a result of air wind blowing over these blades. So, this shaft will rotate at a lower speed, and this shaft is connected to the shaft of a generator with the help of a gearbox, and this gearbox helps to increase the speed of shaft speed of the generator. As a result, we will obtain electrical energy in this case. So, here also the concept of generating electrical energy is same. We are trying to rotate the shaft of the generator. Then we will go for the solar energy. So, sun is considered as the ultimate source of energy of this planet Earth. Without sun, we cannot imagine for survival here on this earth. So, it gives the energy to the plants, and human beings are fully dependent on these plants. So, in addition to this one, we use the solar energy for our day to day life for basic purposes like drying the clothes, drying the fruits, vegetables, including your fish also we are using. Even we are also getting salt out of this sea water with the help of the solar energy, where we evaporate the water and we are able to collect the salt here. So, now we can think of getting electricity out of the sun for our day to day requirement. So, this have also been already achieved by this human being. So, there is a something called your solar cell. So, this shows a street light running with the help of a solar cell, where we convert this solar energy into electrical energy through some technology, where we take the help of silicon diodes. But this concept of getting electrical energy is totally different from the way where we get electrical energy in case of a thermal power plant. So, we will not discuss this in detail, but there is another way where we use the same concept similar to that of a thermal power plant, where we are getting electrical energy. So, here also we will use this solar energy for getting electrical energy based on the same concept, that is called heliostat based thermal power plant. So, in this heliostat based thermal power plant, we focus the solar energy falling at a larger area to a smaller area called a central receiver with the help of mirrors placed around this one called this heliostats. These mirrors will change its inclination with respect to time because of the change in the position of the sun, so that every time the solar energy will be directed towards the receiver. So, at the receiver the intensity of energy will be very high. So, here we can convert this water into steam, and this steam can be used to run a turbine, and from the turbine you will obtain the electrical energy. Again, here that steam coming out of this turbine, that will be at low pressure steam, can be condensed again with the help of a steam condenser, again reused here. So, here the concept is exactly same to that of running a thermal power plant, except that here instead of using coal or any other fuel as the source of energy, here we are considering the intensity of sun or the energy contained in the sunlight as the source of energy for converting water into steam. So, this shows the actual photograph of a heliostat based thermal power plant. Here at the center it can be seen that central receiver tower, and around this large number of heliostat mirrors are placed, which reflect the sunlight falling on this directly toward the central receiver. So, this explains the phenomena. Here it can be seen, this is your central tower where receiver is placed at the top, and these are the heliostat mirrors placed at the ground. So, they change their inclination with respect to time depending on the position of the sun, so that sunlight falling on a particular mirror gets reflected such that it will fall on the receiver, and here at the receiver we will convert the water into steam because of high intensity of heat gathered at a smaller area. So, this shows the actual photograph of a heliostat based thermal power plant. Here it can be seen the sunlight falling on these mirrors are being reflected to the top of this central receiver tower. Next, we will go for the working of a tidal power plant. Here we take the advantage of rise in the sea level, that is because of tides coming due to the position of the sun and moon at a different times. So, here we construct one small dam, and when this sea level rises, water will enter inside this dam. Then when sea level starts falling, we will block the gates. Then there will be a passage through which we will allow this stored water to flow back into the sea through a small controlled passage. Along this passage there will be a turbine. So, when this water here on the inside this dam will be at a higher level, and the sea level will be lower because the water level is decreasing here. That is why naturally the water will start flowing from this high water mark reservoir towards the sea, and as a result the turbine will rotate, and this turbine will run a generator, and from the generator will obtain the electrical energy. So, here also the concept of obtaining electrical energy is same, that means rotating the shaft of a electrical generator. Then you will go for geothermal energy. So, the underground of the earth is at a relatively higher temperature containing lot of thermal energy inside it. So, this thermal energy can be used by allowing water flowing through this, so that this water will gain the heat contained underground, and this will convert the water into steam, and this hot steam can be used to run a turbine, which will in turn will run a generator to give the electrical energy. So, once we run a turbine, then we will obtain a low pressure steam, which can be again condensed back, again fed into the underground, so that we can again re-extract the geothermal energy from the underground of this earth. So, here also the concept of obtaining electrical energy is same, that means the rotating the shaft of a electrical generator. So, that means we need to consider rotating the shaft of electrical generator, whatever be the source of energy we consider for rotating the shaft. So, in every case our objective is the same, to create rotational effects so that it can be used to rotate the shaft of a electrical generator. So, now we will see the details of the course content that we will cover throughout this subject. This shows the schematic of thermal power plant, which I have already explained. This is the boiler where we feed water with the help of a pump into the boiler. With the help of the fuels, we convert this water into high pressure steam. This high pressure steam goes into a turbine, and at the turbine low pressure and low temperature steam leaves. Then it is condensed with the help of a condenser by using coolants. Then in the condenser, this low pressure steam is converted into water, and this water is again fed back into the boiler. So, this completes the cycle here. So, here the main components of this thermal power plant is a boiler, turbine, condenser and the feed pump. So, here first we will learn the basic theory based on which this thermal power plant is working, that is called the vapor power cycle. So, here we will study in detail about what is a vapor power cycle and how we obtained the idea of this vapor power cycle, whose origin is the theoretical Carnot cycle. Then we will study different ways through which we can think of to increasing the overall efficiency of this thermal power plant. So, next we will go for study in detail the construction and the working of a boiler, also known as the steam generator, where we are converting water into high pressure steam. Next we will go for studying the construction and the working of a nozzle, which is prime in the working of a turbine. So, once we study the working and the design of a nozzle along with its thermodynamic principle, next we will go for the construction, types and working of a steam turbine, where we will study in detail about different types of steam turbine and the underlying thermodynamic principles based on which this turbine works. Next we will go for condenser, where we will study different types of condenser. Then next we will go for the study of nuclear power plant, which is basically nothing but a thermal power plant, where instead of using coal or any other fuel, solid or liquid fuel as the source of energy, we consider nuclear fuel as the source of energy. So, here in this case, the overall concept of operating the power plant is same, except that we replace this boiler, conventional boiler, by a boiler where we use this nuclear power, is known as a nuclear reactor. So, there we will study in detail the working, construction of a and the basic principle of a nuclear reactor. The other things remain as it is in case of a nuclear power plant, similar to that of a thermal power plant. Regarding reference books to be used for the subject, so it is very difficult to recommend a single textbook which will cover all the aspects of this courses to be studied here. So, here I have listed some books that can be referred back time to time. So, first book is your Power Plant Technology by L. Wakil from Tata McGraw-Hill publication. So, next there is a book titled Thermal Engineering from Norosa publication, authored by Ajay Kumar and G. N. Shaw. Here this book covers the power plant technology in addition to thermodynamics and other aspects of thermal engineering. So, part of this book will be useful for this subject and remaining part of this book may be useful for some other subjects. Then there is a book titled Power Plant Engineering by P.K. Nag from McGraw-Hill publication, dedicated for this subject. To study in detail about the working of a turbine, this book by R. Yadav is a very good one. So, recently they have included other aspects of power plant engineering in addition to the steam turbine. Then for detailed study of working of a turbine, so the book by S.M. Yaha can be very much useful. Then there is a generalized book titled Thermal Engineering by M.S. Rathore from McGraw-Hill publication, which covers the whole of this power plant engineering in addition to other aspects of thermal engineering, including thermodynamics. Here I have listed some more books for further reading, like Basic Engineering Thermodynamics by T. Roy Choudhury from Tata McGraw-Hill publication. Then Power Plant Engineering by Black and Vetch from Kluwer Academic Publisher. And since already I have told you, the fundamentals of thermodynamics is very much essential for studying the subject power plant engineering. So, here it is listed some books on thermodynamics also, like this T. Roy Choudhury. Then there is a good book on fundamentals of thermodynamics by Sontag, Van Wylen. Then there is another good book for thermodynamics by Moran and Shapiro, and another book on thermodynamics by Sengel and Bowles. In addition to textbooks, students are also encouraged to refer to NPTEL video lectures on different subjects, where some of the courses have been dedicated for this subject, and sometimes some part of this video lecture courses have been dedicated to topics to be covered throughout this subject. Regarding the evaluation process, it will consist of traditional evaluation consisting of 3 modes. One will be your midsem, where 30% credit will go to this one. Then we will have an end semester exam, 50% of this credit will go to here. Then the internal evaluation for which 20% credit will go, which includes your regular assignments and quizzes and attendance of the student in the class. There is an organization called International Energy Agency, which is working together with its member countries and non-member countries towards ensuring reliable, affordable and clean sources of energy. India is a non-member country to this International Energy Agency. So, there is a dedicated website of this organization, iea.org, where lot of information can be obtained related to energy, like your key world energy statistics can be obtained here on this website. This slide shows the coal scenario over the of the different countries of this world. So, the first table shows the top producers of coal in the world. So, here you can see India is positioned at the 3rd place. We are producing around 8% of this total coal production of this world. And then the second table shows the importers of this coal, where India is also positioned at the 3rd place. Then the third table lists the list of exporters, where you will see India is not positioned here in this list. The basic reason behind is that though we are producing lot of coal, we are also consuming a lot of coal. So, that is why we need to also import from the other countries. Considering our population is very high, second highest in the world, there is a requirement of lot of energy, and we are heavily dependent on this coal as the primary source of energy. That is why in addition to having lot of production of coal, we are importing, but we are not exporting any amount of coal to any other country. So, this slide shows the importance of thermal power plant for a country like India. So, that is why we are going to study this subject thermal power plant engineering in detail throughout this subject. This shows the installed capacity by source in India as of 30 November 2006. Here it can be seen we obtained our energy requirement from coal, which is more than 60%, whereas other sources like your hydro energy is around 15%, wind power is around 9%, solar power is around 3% only. nuclear is very small, around 2% only. So, here also you can see how the thermal power plant are important for the development of our country like India. And that is why there is a dedicated ministry under Government of India which look into the energy requirement of India, where they make policy decisions etc. So, the details information can be found on the website of this Ministry of Power, that is powermin.nic.in, where lot of information related to generation, distribution and transmission of electrical energy can be found here, in addition to other sources of energy. Then there is a Ministry of Statistics and Program Implementation, which periodically provide the energy statistics of our nation. So, the details can be found at their website, that is mospi.gov.in. The recent energy statistics for the year 2016 is available on this website, where a detailed information regarding energy in relation to our country India can be found. Then there is a organization called Bureau of Energy Efficiency, which is a statutory body under the Ministry of Power, Government of India, whose tagline is energy is life, so conserve it. So, this organization was created in 2002, which develops programs which will increase the conservation and efficiency use of energy in India, because our production capacity is very limited and our consumption or demand are increasing day by day because of development in science and technology, along with continuous increase in the population. That is why conservation is an important aspect for the development and growth of our nation. That is why this organization is working towards this one. So, there is a Energy Conservation Act 2001 passed in the Indian Parliament. As per this act, it is mandatory for all appliances, that is basically electrical appliances in India, to have ratings by this Bureau of Energy Efficiency, also known as the BEE, starting the year January 2010. And the mission of this organization is to institutionalize energy efficiency services and enable delivery mechanisms in the country, and to provide leadership to energy efficiency in all sectors of the country. And the objective of this Bureau of Energy Efficiency is to reduce energy intensity on the Indian economy. So, you will see on every electrical appliances, if you want to purchase, it will contain some stars similar to as shown here in this picture. So, this stars basically tells you the way how in which this electrical appliance is consuming the energy. So, the more the number of stars means the less is the power consumption or more is the power saving. That is why whenever you are going for purchasing an electrical appliances, you should look for this B star level, and for which the detailed information can be found at their website bstarlevel.com. So, it is mandatory, it is very important for saving energy for the benefit of ourselves, to save money, as well as for the benefit of our nation, to have a strengthened economy in the world. There is some certification course provided by the Bureau of Energy Efficiency, which retained this National Productive Council as the national certifying agency, which conducts these examinations and certify people as the energy auditor and energy managers. As per the Energy Conservation Act 2001 passed in the Indian Parliament, it is mandatory for all the designated consumers to appoint an energy manager, which will go for the management and the audit of the energy. So, this Bureau of Energy Efficiency has been empowered to specify the qualification criteria and the procedure for the certification of these energy managers and energy auditors. So, periodically twice every year this examination is conducted. This is known as the National Certification Examination for Energy Manager and Energy Auditors. So, engineering graduates can think of making a career in energy manager and energy auditors, considering its importance from the Indian energy sector point of view. So, For regarding this career options, students can refer to this link where the recent advertisement for this said examination is released. For the certified energy auditors examination, this graduate engineering students are eligible who have already acquired 3 years of work experience involving the use of the energy in operation, maintenance, planning, etc., where they can think of making a career as energy auditors. So, they can have their own consultancy firms or they can be employed by the other organizations. So, these are the papers which need to be covered for the appearing these examinations. So, which covers the basically the energy efficiency in thermal utilities, energy efficiency in electrical utilities and energy performance assessment for equipment and utility systems. So, basically it covers the fundamentals of energy management and energy conservation. So, we will conclude today's talk with this. Then from the next class we will start to think how the human being got the idea of using water as the primary source for obtaining the motive force, so that it can be used for the rotation of a generator shaft, from which we will obtain the electrical energy. Thank you.